back. This is the second part of the video for the first day. There'll be 3 parts actually, because you're going to look at polyatomic ions as well today. But the second part has to do with anions. I wanted to break it up, one with cations, one with anions, in case you have to go back to it later on in the units. Usually you have to go back to cations just for a little bit of a reminder, because anions are pretty consistent. Anions are any element, atom, that is going to gain electrons. So you're going to have more negatively charged electrons than your positively charged protons. So because you have more of those negatively charged electrons, these end up with a negative charge. So positive charges are cations, negative charges are anions. And with your anions, these are your non-metals. So if we go to my document camera real quick, and when we look at this, in the last unit, over the periodic table, we had metals, we had nonmetals, we had metalloids. And with this metalloid characteristic, they just have characteristics of both metals and nonmetals, so they kind of get trapped in the middle. However, the ones that are on the left-hand side of the stair step have more metal characteristics. The ones on the right-hand side have more non-metal characteristics. So we're going to get rid of the metalloids. They're kind of weird. They're in a weird spot. We actually don't even use them very often for bonding at all. But our periodic table now looks like this, where you have your pink that are all of your metals, your yellow, which are your non-metals, and then you have hydrogen up here, which is a non-metal as well. However, it can have a +1 charge. Hydrogen kind of falls in the middle between these two because it could make a cation, it could make an anion. So hydrogen now has a +1 charge. However, when we get to these anions, your non-metals over here, it can also form an anion. So with the metalloids, I just explained this, we just got rid of them, so I'm going to skip over that since I just explained it. So now we're back to our different anions, and when we look at them on the periodic table, their oxidation numbers, their charges, use the periodic table still. So if you have anything in group number 17 down here, these all have a -1 charge. Group number 16 all have a -2 charge. Group number 15, -3. Now I'm just talking about the yellow elements, your non-metals. Yes, you have antimony and bismuth and polonium. We don't really deal with those. So don't worry about that little section right there. This carbon group, carbon and silicon, these make a -4. All nonmetals all gain electrons, and that's because we said that these are a +4 or -4. Your metals down here are all your positive charges. Your nonmetals up here are all your negative charges. So carbon and silicon are negative, germanium, tin, and lead are all going to be positive. So when we're looking for your oxidation numbers, as long as you have a periodic table handy, I would, if I were you, if you got the cardstock periodic table or one of your 900 periodic tables that you've colored so far, I would have one handy, and I would write down these oxidation numbers just like I have written up here. I would also make note that if you have anything in your transition metals, you need Roman numerals. And then also in the last video, we've talked about zinc is always +2, silver is always +1. So these are things that might be helpful for you to write down on a periodic table as we go through the nomenclature units. Now I did say that I was going to come back to hydrogen. Hydrogen is really strange. It could make a +1 oxidation number. It has 1 valence electron, and sometimes it gains an electron in order to form a full valence shell. Hydrogen can also make a -1 charge. It's not as common, but it could. So I just wanted to point that out, that hydrogen could be +1 or -1, but everything in the first group are all +1. Now when we go to name these, you're going to have a list of them, but what you have to do is you have to drop the last part of the name, and whatever the last part of the name is, you're going to add in IDE. IDE. So when we're naming these, if we have something like O with a -2 charge, O is oxygen. Oxygen, when we drop the last part of the name, and there's no real like steadfast rule on this, as long as you attempt it and it ends in IDE, I'm good. But this one is oxide. So oxygen with a -2, the YGEN goes away and it turns into oxide. Fluorine, you might have heard of this one before at the dentist. This one turns into fluoride as an anion. Chlorine, the IDE goes away again, it becomes chloride. Phosphorus, again, the last part of the word goes away and it turns into phosphide. So we have oxide, fluoride, chloride, phosphide. When we look at all of them from the periodic table, sometimes, especially if we're in class, I put this up on the board and I said, hey, you might want to write this down on the back of your periodic table or something so you have it handy or on a little slip of paper until you get used to them. You're going to use nitride, oxide, fluoride, phosphide, sulfide, chloride, bromide, iodide over and over and over. You're going to know those pretty quickly. Telluride, you're not going to see very often. Selenide, again, you're not going to see that very often. But this is hydrogen, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, arsenic, selenium, bromine, tellurum, and iodine. These are all when they turn into anions. You just drop the last part of the name and it's going to end with IDE. So again, when we have something, if I go back a slide, like this one, that fluorine becomes fluoride when it has a charge. Chlorine becomes chloride when it has a charge. So your anions are the ones that change the last part of the name. Cations do not change at all. They are always going to stay the same as we go through our nomenclature. Cations stay the same. Anions, you're going to drop the last part of the element name and you're going to change it to end with IDE.